All right, peeps. Yeah, if you're on the slide that looks like this, on here it's slide 11. Grab the packet on top of the fridge. The packet on top of the fridge should look like this. All right, now look, you're on your own as far as the name goes. You're on your own for the core. If you can't fill those out, jeez. All right, this one here, part one, electromagnetic radiation. All these right here. All right, you just have to Google those and get a definition. Now, look, with that, you don't have to put the whole Google definition. Put in your own words, put your own spin on it, something you're going to remember. That's what I'm looking for. Down here, uh, circle good or bad. Greenhouse gases are good, bad absorbers. So they must be good, bad radiators or infrared energy. Give this one a think on that one. So you're either going to circle good or bad, and then down here, circle good or bad. Do you feel we need or do not need greenhouse gases, and why? Um, Tell me what you think. All right. Back it up, your reasoning. Down here, this is more Google right here. All these right here. I will say this, the one for nitrogen dioxide, you can do, instead of the percent, you can do the parts per billion, the ppb. All right. If you're listening to this, I think it's 10. That's for this answer right here. Now for this one, this is where you're actually going to need the sim. So you go up to this and you go click on this sim and you're like, yeah. All right. You're probably not like, yeah, but whatever. All right. Now this one here, you're going to say it doesn't load. Yeah, it does. You just hit this play button. Now here it is loading. Yep. Here we go. So the first question asks on your piece of paper, what are the four lights that are shown and which one can the human eye see? Well, the four lights are down here. Here's one, there's two, there's three, and there's four. As far as which one can the human eye see, I don't know, man. It's pretty self explanatory. All right. Next question. All right. Select the visible photon. Oh, did we do that already? Yeah, we did. We clicked visible photon right there. Then press the green button on the flashlight. Then click on the different gases. Which gases did the visible photons go through and which ones were absorbed and radiated? Why do you think this is so? So we're going to this. We're going to hit the green flashlight. Oh, yeah, it's just nuking them. It's going right through. It's going right through carbon monoxide. Gee, golly whiz, it's going through nitrogen. It's going through oxygen. It's going through carbon dioxide. It's going through methane. It's going through water vapor. All right. Now, nitrogen. Oh, wait a minute. Oh, geez. Oh, wait. Nitrogen dioxide's a little different. So, some of them go through and then some of them get re radiated, like out. Okay. And then ozone right here, it just keeps blasting and right through ozone. So, it goes through all of them except for nitrogen dioxide. Um, um, which was, it went through all of them except nitrogen dioxide. Why do you think this is so? Because basically our Earth has to allow sunlight, the atmosphere has to allow sunlight in. Otherwise, we wouldn't have heat. No heat, no plants. No, I'm sorry, no sunlight, no heat, no plants, no cows, no cheeseburgers. You know, if the gases of the Earth's atmosphere absorbed and re radiated visible light, what would happen? So if the greenhouse gases absorbed incoming sunlight and then bounced it out, it would act like a mirror or shield and it would not let any sunlight get to the earth. If no sunlight got to the earth, what would happen to the temperature? All right. What can you conclude about the transparency of the Earth's atmosphere with regards to visible energy? It just lets it come on through. Yep. It just basically, that's what it lets it do. All right. Now down here. Now click on the infrared light button. So we go to this and we click the infrared button like that, right? Ooh, all right, we're cheating. All right, now to analyze how well each atmospheric gas absorbs and re-radiates infrared energy, fire 10 photons. You might need to change the speed from normal to slow at each gas and calculate the percentage of the photons absorbed and re-radiated. Fill in table 1 below. So here's how you do this. So you're going to click on CH4 right here. Good. Because that's the one we start off with. Now, this helps if you have two partners to help you out. One partner is going to count to 10. The other one's going to count the number that makes the molecule jiggle, for lack of a better term. So watch this. I'm going to start off. I'm going to put it on slow. I'm going to put it on pause. All right. We're going to count this as the first particle right here. And then I'm also going to count the number of the jiggle. So I can do both, but you're seriously better off having one partner be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then having the other partner be like one jiggler. Oh, that one got through. Two jigglers. Okay, that one got through. Three, and so forth. Here we go. Counting to 10. Okay, so that was 10. That was 10 that went through. Out of the 10, three of them jiggled. So what I would do is I would go in here and I would write 3. And now here's where math matters. And don't tell your math teacher I'm telling you this trick. So we did 10 photons. So 3, because it's out of 10. So 3 times 10 is 30. Boom. All right. Now, so this number over here, the number that got transmitted, the number that went through, if we did 7, if we did 10 and 3 of them jiggled, that means 7 of them did not. But we're also going to multiply that by 10, so it makes it 70. You got it? Then you're going to do it through the rest of them. So CO2, you're going to switch that off to CO2 like this, and then you're going to count through and do the same deal. All right? All right. I got to delete these because otherwise I'll print them off. All right, good. Based on the results, which gases contribute to the greatest to warming the Earth's atmosphere? Do these gases make up a large percentage of the Earth's atmosphere? Be specific. So, what you have to do is go through here and probably look at the ones that absorb the most percentage wise. And then those are the ones that contribute to the greatest to the Earth's warming of the Earth's atmosphere. As far as do they make up a big percentage, that's where you go back to this and you take a look at these. All right. All right. So that's for that question. Now, for number 6, evidence from many scientific disciplines has shown that the Earth's climate is experiencing a warmer trend. The addition of which of these gases has contributed to the greatest increase in global temperature? What are some of the anthropogenic human-made sources of this greenhouse gas? So look at what so out of the gases, which one has contributed the most to global warming? And then what are some of the human-made ways we put that off in the atmosphere? So based on the results of this part of that, we're going down to this one. Based on the results of this part of the lab, describe using the terms in the vocabulary section how increases in greenhouse gases such as CO2 and methane can lead to a warming of the Earth's atmosphere. So what you are to do is this. Use all the vocab that you can right here, at least as much of it as you can. And then go into here and, describe how increases in the greenhouse gases such as carbon dioxide and methane can lead to a warming of the Earth's atmosphere. All right. And that's part 1 for you. All right. Good luck.